Welcome to this lesson on transformations. Please make sure you have a calculator and a whiteboard or maybe a piece of paper to take some notes. Our goals for today are to be able to write a transformation of given functions in our equations, to graph original functions and the transform function. For this, we're going to need our calculator. So again, can't stress enough, you need a graphing calculator to do this. And then we're going to identify the types of transformations. Well, the types of transformations that we might describe is a translation either up or down, maybe a translation goes left or goes right, a reflection, it might stretch or compress. Now, stretch is another word for maybe you might say the graph gets wider, whereas a compression, that's the fancier word for a graph that gets skinnier. So you will be able to write a transformation, graph using your calculator, and describe the transformation. Here's your first example. We have f of x equals x squared, and g of x equals 3 times f of x plus 2. The way these are written, I'm going to be able to begin with g of x, and what I'm going to replace is I see f of x right here, I see f of x here. The equation for f of x is x to the second power. So what I do is I always start with g. I rewrite g, but I leave space where I see any functions that I'm going to plug in. And I'm going to replace f of x in parentheses with its function, x squared. Now once I do this, I can distribute, and I can rewrite this as 3x to the second power plus 2. Now here is where we are going to need to graph our function. So I've got my new function g of x, which we rewrote from the previous screen, and we've got f of x, which is x to the second power. So grab your graphing calculator, go to your y equals button, and type the equations in. I want you to pause the video because I'm going to go to the next slide. Here's what it should look like. You go to graph. You should be able to type in f of x. I would type the x squared in to y1, and I would type the g of x in for the y2. And when you go to graph, you'll notice that the first graph comes first, and I'm going to do my best to trace it in blue. There's our f of x. And the g of x is this function right here. So when you go to draw this, you just make a nice sketch of what it looks like. Now I need to describe the transformation. Well, what happened from the blue graph to the green graph? Well, it looks like it translated up, and it also compressed. Okay, it moved from this, our vertex was down here, the vertex moved up, therefore it goes up, and it looks like it gets a little skinnier, so it compressed. Let's go to example 2. We have f of x equals negative 1/2 x squared, g of x equals 2 times f of x minus 3. A little different example, but I always start with g of x. Rewrite it 2 times, that's on the outside. I'm going to have to leave space because I'm going to put something inside there. Now notice this thing different. We have, instead of f of x, it says f of x minus 3. So that means I need to put x minus 3 inside the f equation. So f of x minus 3 looks something like this. Negative 1/2 x minus 3 goes in for x, and we have it squared. This is what I'm going to plug in right here. So we have 2 times. I'm going to have negative 1/2. Instead of just the x, I need to plug in x minus 3. So I got parentheses to do that. squared. Now, I'm okay if you leave your function just like this. If you were to simplify this, you would have to go on the side here and do x minus 3 squared, which is x minus 3 times x minus 3. You would have to FOIL. You would get x squared minus 3x plus 9. So x squared minus 6x plus 9. So we have 2 times negative 1/2 x squared minus 6x plus 9. Now rather than distribute the 1/2 and then distribute the 2, mathematically we can do this. 2 times negative 1/2 would just be negative 1 x squared minus 6x plus 9. And we can distribute the negative 1, changing our signs, in which we get negative x squared plus 6x minus 9. So if you were to simplify, it would come down to negative x squared plus 6x minus 9. I am okay if you just plug it in, you leave it just like this. So again, we've got f of x equals negative 1/2 x squared, and g of x is either one. Either you leave it in this form, or if you simplified it, it would be written in this form. Pause the video, type this into your calculator, see if it matches what I get on the next screen. So I typed this in as I used f of x up top for y1, and I typed in g of x for y2. Notice how I used this form instead of the simplified form. It's alright. Now we look at the graphs here, and my f of x is this first graph that comes around like this, and my g of x follows this path. So the transformation, look at the vertex. The vertex started here and it moved to the right. So we can say it moved to the right. And also, it looks a little bit skinnier, so we could say that it compressed. So it goes to the right and it compressed. That is how we describe the transformation. Let's look at example 3. We have f of x equals x cubed minus 3x plus 2. G of x equals f of 1/2 x. To write the transformation, whenever you see a number inside here, this is what we are going to plug in for each x in the function. So let's rewrite f with some parentheses. So we have parentheses cubed minus 3 times something plus 2. Well, we're going to put 1/2 x for each x in my function of f. Now again, you can leave it as this form. But if you were to simplify it, you would take 1/2 to the third power, which would be 1/8 x to the third power minus 3 times 1/2 would be, we can go with a decimal, 3.5x plus 2. Now, either one works. You can use the simplified version or the original. So again, we're plugging in x cubed minus 3x plus 2, f of x. Plugging in g of x, either one works. So, either one works. Pause the video now to type it into your calculator. You look, we have y1 is in blue. G of x is going to be our y2. And I plugged in using the simplified form. So again, either way works. If you're afraid about the simplified form, just leave it in the original form. So my f of x is this graph right here. And g of x is this graph right here. Again, I know I didn't trace it very well, but they both cross at the same point. Therefore, it doesn't go to the right or to the left. The only thing it does is it is a stretch. Or you might say it got wider.